Angle proofs are proofs just like geometric proofs, what we did earlier with segments. They're just proving from step to step how do you reach a conclusion, final conclusion. And angle proofs are going to be a little bit more challenging than segment proofs because there are a lot more definitions. You have to know vertical angles, supplementary angles, linear pair, definition of a right angle. You have to know complements, definitions of supplements. You have to know all your vocabulary at this point. If you don't, you will not be successful. So at this point, you should have a graphic organizer of all your properties and theorems so far, and we will always be adding to it as we go along. But if you think that you can just get by with just watching and paying attention, you're wrong. You really have to know these and have all these memorized. Okay, so let's take a look at the first one. Given angle 1 is congruent to angle 2, angle 2 is congruent to angle 3, so I can still use one arc here. Angle 3 is congruent to angle 4, I can still use one arc because, you know, they're all congruent to each other. We want to prove that angle 1 is congruent to angle 4. Well, just looking at the picture, we can pretty much tell that it is, but the way that geometry works is nothing can be established until it has been officially proven. So you have to do that by justifying everything that you do. Okay, I'm looking at statement number 1. It says that angle 1 is congruent to angle 2, and we have that in our given. Angle 2 is congruent to angle 3. That's in our given. And then it stops there. So we left out this angle 3 is congruent to angle 4. That's okay, but just remember that we left that out because in the future it's probably going to show up back here somewhere in the proof. And the reason will still be given. So number 1 is given because those two things were given to us. Now number 2, we have angle 1 is congruent to angle 3. Well, that's not the one that was left out, so it must have come from somewhere else. Well, I'm going to take this first part and write that as my if to figure out how I got here to my conclusion. So I'm just going to write this linearly. If angle 1 is congruent to angle 2 and angle 2 is congruent to angle 3, why is it that angle 1 is congruent to angle 3? How did I reach this conclusion? Well, look what we have here. 1 stayed the same, 3 stayed the same. Our middle terms dropped out. It looks like law of syllogism, but we call it the transitive property. And now that instead of transitive property of equality, we're now dealing with congruency symbols. So this becomes the transitive property of congruency. Okay, statement number 3 says that angle 3 is congruent to angle 4. I see a bunch of 3's up here, but we haven't really said anything about angle 4. So I'm going to come back over here and see if that was what was missing from our original given. And here it is again. So this one is just given. Then we're told that angle 1 is congruent to angle 4. Well, once again, I need to look for a pattern, and these are really hard because it's not straightforward as much as the angle or as much as the segment addition ones or as much as the algebraic proofs. These you really have to search for, and you'll start to do them over and over and you'll get a feel for it. But I'm going to take my angle 1 is congruent to angle 3 and make that an if. I'm also going to make this my if, and then my final conclusion is that angle 1 is congruent to angle 4. And I'm going to write them linearly again. So I'm taking the angle 1 is congruent to angle 3, and angle 3 is congruent to angle 4, and my conclusion, my then, is that angle 1 is congruent to angle 4. So if you look at it linearly, the 1 stayed in, the 4 stayed in, but the middle terms dropped out. And that's the transitive property of congruency again. Alright, there is another theorem that we need to add to your list of theorems that you need to know. It's called the right angle congruence theorem. And it just says that all right angles are congruent. And I know that sounds simple and basic, but it's just an easier way of going from one step to another without having a whole bunch of steps in between. So what I'm actually going to do here is I'm going to prove this theorem. Remember, a theorem is something that needs to be proved, so I'm going to show you the proof of it. And then in the future, you can just stop. You can skip steps and go from this step to this step without any steps in between, because we're going to prove it right now. So the given is that angle 1 and 2 are right angles. And we're trying to prove that angle 1 is congruent to angle 2. Well, that's pretty obvious. It seems like a no-duh kind of thing, but we are just going to do the proof. Angle 1 and 2 are right angles. That was given to us. And why are we allowed to replace angle 1 and angle 2 with the measure of angle 1 equals 90 degrees and the measure of angle 2 equals 90 degrees? Well, what we're doing here is we're just defining what a right angle is. And the definition of a right angle is that the measure of a right angle is 90 degrees. So we're replacing angle 1 being a right angle with the definition of a right angle, which is that it equals 90 degrees. So we're just defining, or we're just giving the definition of a right angle. I'm just abbreviating here. All right. Now how do we go from this step to this step? Well, we said that angle 1 is equal to 90 and angle 2 is equal to 90. So because they both equal 90, then they both equal each other. So I'm replacing this 90 here with what it equals, which is the measure of angle 2. So I've just substituted in measure of angle 2 for that 90 degrees. Okay, and then my last step says that the measure of angle 1 equals measure of angle 2, and then it becomes angle 1 is congruent to angle 2. And all we've done here is we've changed the equal sign into a congruent sign and got rid of the measures. And when we do that, just like with segments, we're talking about the definition of congruent angles. The definition of congruent angles says that angles that are congruent are also equal, or angles that are equal are also congruent. So it's called the definition of congruent angles. So now we have proven this right angle congruence theorem that says all right angles are congruent. So in the future, you're going to see something like this. You're going to see angle 1 and angle 2 are right angles. And then the next line will be that angle 1 is congruent to angle 2. And you won't have all these in between. And the reason for that is what we just proved. You would say that is the right angle congruence theorem. All right, the next theorem that we're going to add to your reason bank is the Congruent Supplements theorem. It's just like the right angle congruent theorem, and it just says that if two angles are supplementary to the same angle or congruent angles, then they're congruent. So you're going to see a series of steps here. If I had your given here, your statements here, and then your reasons here, you would see this first half under one line. So you would see that the measure of angle 1 plus the measure of angle 2 equals 180. And the measure of angle 2 plus the measure of angle 3 equals 180. Your reason for seeing that statement would be a given. They would give that to you. Then in your next line, you would see that angle 1 is congruent to angle 3. It looks like they replaced the measure of angle 2's here, and they got rid of this 180, and then they just set 1 congruent to 3. It kind of looks like a roundabout transitive property. It kind of looks like a roundabout substitution property. But all they're doing here is saying that any sets of congruent supplements are congruent. And this one's going to be really hard to see, but you've got to get used to seeing this pattern. You'll be given two sets of angles that equal 180, another two sets of angles that are equal 180, and then, you'll be left with one and the other equal to each other. You're going to see the same thing with the definition of congruent complements. Okay, so here's the congruent complements theorem. You have two angles that are complementary to the same angle, or congruent angles, then they are congruent. So it says angle 4 and 5 are 90, so these two together are 90 degrees. And 5 and 6 are 90, so these two together are 90 degrees. Then we can say that angle 4 is congruent to angle 6. And the reason would be your congruence complements theorem. So the same thing as the last one. We'll have your statements and your reasons. The way that you'll see it is you'll have a pair of angles that are 90 degrees and another pair of angles that are 90 degrees in one of your sets of statements. Okay, so this whole thing would be one of your statements. And of course, this would be given to you. Then your conclusion would be to keep kind of that first and last set of angle pairs. It kind of looks like transitive property and it kind of looks like substitution because we're getting rid of some stuff and we're getting rid of some stuff here. But because these are complements or they're complementary angles, then we call it the congruent complements theorem. Oops. So we can say that the measure of angle 4 is congruent to the measure of angle 5. And that's the congruent complements theorem. Oops, sorry. It's the measure of angle 6. Because it's your first and your last angle are congruent to each other. Alright, so here's where it gets really tricky because you're gonna have a lot of letters kind of meshing together. You're gonna have a lot of theorems all wrapped up in your head. They are hard. You have to really know your definitions and theorems. So in the beginning we were given that DAB and ABC are right angles. So DAB, so this angle is a right angle, and ABC, so this angle is a right angle. And angle ABC, A to B to C, is congruent to B to C to D. So it's congruent, these two. And we want to prove that DAB is congruent to BCD. We want to prove that this angle and this angle are congruent. Well, we already know that if this one's 90 and this one's 90 and this one's congruent to this one, then they're all 90. They're all congruent to each other. But you can't just say that. You have to prove it. So DAB and ABC are right angles. Angle ABC is congruent to BCD. That's both in the given. Then they say that DAB is congruent to ABC. Well, this is where the congruent complements theorem works. We were told that DAB and ABC are right angles. And because ABC and DAB are right angles, they are congruent. Okay, and if you remember what that's called, it's got the word right angles in it, and we established that right angles are congruent, so that's the right angle congruence theorem. And as always, you can abbreviate as long as it's clear what you're trying to say. All right, then down here we have ABC is congruent to BCD. Well, we have ABC is congruent to BCD here. That's weird. All they did here was restate something that was already given. And you really have to watch out for that. Look around, see what patterns are emerging. And sometimes they do introduce the given more than once. If it's straight out written there in the given, then that's how we write it, as given. But the reason they reintroduce that given is because they're setting us up for something. I'm going to take these two terms and call them my hypothesis. And I'm going to see how I got to my conclusion. So I'm going to write these two terms linearly. Angle DAB congruent to angle ABC, and angle ABC congruent to angle BCD. Do you see what's happening here? We are left with our then, which is angle DAB congruent to BCD. So if you see, we kept our last terms, kept our first terms, and we lost all these guys in between. And the two middle terms are the same back to back. It's called the transitive property of congruency. All right, our next definition or postulate to add to our bank of definitions and postulates is the linear pair postulate. And that says that if two angles form a linear pair, then they are supplementary. So what you'll see is in a statement and reason form for a proof, you'll see that angle 1 and angle 2 are a linear pair, and your reason would be given. But then your next statement would be that the measure of angle 1, or would be that angle 1 and angle 2 are supplementary. And that would be the linear pair postulate, because angles that form a linear pair are supplementary. Alright, so let's see this one in a proof. Here we said angle 1 and 2 are a linear pair, and we can look at them and know that that's given to us in the picture. They're just restating it. Angle 2 and 3 are a linear pair. Well, that's given to us in the picture. If you turn it sideways, you can see that 2 and 3 lie on a flat line. And we're asked to prove that angle 1 is congruent to angle 3. Well, we already know that angle 1 and angle 3 are congruent by vertical angles. You know, vertical angle theorem says that vertical angles are congruent. But because we were given this piece of information, we're going to prove it a different way. We're going to prove vertical angles are congruent in a different way. So angle 1 and 2 are a linear pair. Angle 2 and 3 are a linear pair. That's the given. Then we just say that instead of them being a linear pair, we know that because they're a linear pair, that angle 1 and 2 are supplementary, and because they're a linear pair, angle 2 and 3 are supplementary. So we can say that that's the linear pair postulate. Alright, and then this next one, boy does it change. It says angle 1 and 2 are supplementary, and angle 2 and 3 are supplementary, and angle 1 is congruent to angle 3. So it looks like, kind of in a roundabout way, that the 2's are gone, and we're left with 1 and 3, and the supplementaries are gone, and then there's a congruency symbol. There's a whole bunch of different things it looks like we're doing. But if you remember, when you're left with the first and third angle pair, then you're using the definition of congruent supplements. Okay, and that one's really hard to see if you haven't had your flashcards made and completely memorized them, because that's just one of those things that you have to recognize from here to here. That's the definition of congruent supplements. You have a pair of angles that are supplementary and another pair that are supplementary, then you're going to have the first and the third, kind of like the transitive property, angles that are congruent. Alright, and here's the last example we're going to do, and then you're on your own. Alright, given angle 1 is congruent to angle 2, we're trying to prove that angle 1 is also congruent to angle 4, and angle 1 is congruent to angle 2. If they hadn't given that to us and you had just seen the picture, you would actually put that angle 1 is congruent to angle 2 by the vertical angles theorem. Oh, actually I caught my mistake. We are going to change this here to angle 2 is congruent to angle 3. So, because they had that here in the given, in the original given. So, in that way the proof will work. So it says angle 2 is congruent to angle 3. There we go. And we're trying to prove that angle 1 is congruent to angle 4. So angle 2 congruent to angle 3, that's our new given. I just changed it and made it so. And then number 2 says that angle 1 is congruent to angle 2. So here's angle 1 congruent to angle 2, and angle 3 is congruent to angle 4. Here's angle 3 congruent to angle 4. The reason that these are congruent is because in the picture, what kind of angles are these? Well, angle 3 and angle 4 are vertical angles. And so are angle 1 and angle 2. And when you have vertical angles, they are congruent. So the reason we put angle 1 and 2 congruent, angle 3 and 4 congruent, is by the vertical angles theorem. When you have vertical angles, they are congruent. Okay, step 2 to 3, you have 1 and 2 again, and you have 2 and 3 now. And what they've done here is they've taken away the congruency sign between 1 and 2 and the congruency sign between 2 and 3, and they turn them into equal signs. And the definition of congruent angle says that angles who are congruent have equal measures. So we're allowed to interchange the signs. So this is the definition of congruent angles. Then we have angle 1 is congruent to angle 3. Well, from here to here, remember this is my if, this is my then. Our original if is the measure of angle 1 equals the measure of angle 2, and the measure of angle 2 equals the measure of angle 3. And our then is that the measure of angle 2 is, or sorry, measure of angle 1 equals the measure of angle 3. What has happened here is we've crossed out the middle terms. We're left with the first and the third. That's the transitive property. So you'll kind of see them written like this. First and the third, that's your transitive property. And this time it's of equality because these are equal signs. And then the last one, measure of angle 1 is equal to measure of angle 3. Well, this whole proof is all messed up. It should be the measure of angle 1 is congruent to the measure of angle 3, and that should have been what we were trying to prove. Oops. Measure of angle 1 is congruent to measure of angle 3. What a mess. This was just a messy. Bad job, Miss Flip. But anyway, you get the idea. Change from an equal sign to a congruent sign. That's the definition of congruent angles. All right, now you're ready for your exit quiz and get ready for your test. You've got the test review after this and a test coming up. Good luck.